Welcome back. In the last video, we evaluated our multi-class classification model visually, and we saw that it did pretty darn well because our data turned out to be linearly separable, so our model, even without nonlinear functions, could separate the data here. However, as I said before, most of the data that you deal with will require some form of linear and nonlinear function. So just keep that in mind, and the beauty of PyTorch is that it allows us to create models with linear and nonlinear functions quite flexibly. So let's write down here, if we wanted to further evaluate our classification models, we've seen accuracy. So accuracy is one of the main methods of evaluating classification models. So this is like saying, out of 100 samples, how many does our model get right? And so we've seen our model right now is at testing accuracy of nearly 100%, so it's nearly perfect. But of course, there were a few tough samples, which, I mean, a little bit hard. Some of them are even within the other samples, so you can forgive it a little bit here for not being exactly perfect. What are some other metrics here? Well, we've also got precision, and we've also got recall. Both of these will be pretty important when you have classes with different amounts of values in them, so precision and recall. Accuracy is pretty good to use when you have balanced classes. So this is just text on a page for now. F1 score, which combines precision and recall. There's also a confusion matrix, and there's also a classification report. So I'm going to show you a few code examples of where you can access these, and I'm going to leave it to you as extra curriculum to try each one of these out. So let's go into the keynote. And by the way, you should pat yourself on the back here because we've just gone through all of the PyTorch workflow for a classification problem. Not only just binary classification, we've done multi-class classification as well. So let's not stop there though. Remember, building a model, evaluating a model is just as important as building a model. So we've been through nonlinearity. We've seen how we could replicate nonlinear functions. We've talked about the Machine Learning Explorer's motto, visualize, visualize, visualize. Machine Learning Practitioner's motto is experiment, experiment, experiment. I think I called that the Machine Learning or Data Scientist motto. Same thing, you know? And steps in modeling with PyTorch, we've seen this in practice, so we don't need to look at these slides. I mean, they'll be available on the GitHub if you want them, but here we are. Some common classification evaluation methods. So we have accuracy. There's the formal formula if you want, but there's also code, which is what we've been focusing on. So we wrote our own accuracy function which replicates this. By the way, TP stands for not toilet paper, it stands for true positive. TN is true negative, false positive, FP, false negative, FN. And so the code, we could do torch metrics. Oh, what's that? But when should you use it? The default metric for classification problems. Note, it is not the best for imbalanced classes. So if you had, for example, 1,000 samples of one class, so number one, label number one, but you had only 10 samples of class 0. So accuracy might not be the best to use for then. For imbalanced data sets, you might want to look into precision and recall. So there's a great article called, I think it's Beyond Accuracy, Precision and Recall, which gives a fantastic overview of, there we go, this is what I'd recommend. There we go, by Will Koeshren. So I'd highly recommend this article as some extra curriculum here. See this article for when to use precision recall. We'll go there. Now, if we look back, there is the formal formula for precision, true positive over true positive plus false positive. So higher precision leads to less false positives. So if false positives are not ideal, you probably want to increase precision. If false negatives are not ideal, you want to increase your recall metric. However, you should be aware that there is such thing as a precision recall trade-off, and you're going to find this in your experimentation. Precision recall trade-off. So that means that generally if you increase precision, you lower recall. And inversely, if you increase precision, you lower recall. So check out that just to be aware of that. But again, you're going to learn this through practice of evaluating your models. If you'd like some code to do precision and recall, you've got torchmetrics.precision or torchmetrics.recall, as well as scikit-learn. So scikit-learn has implementations for many different classification metrics. Torchmetrics is a PyTorch-like library. And then we have F1 score, which combines precision and recall. So it's a good combination if you want something in between these two. And then finally, there's a confusion matrix. I haven't listed here a classification report, but I've listed it up here. And we can see a classification report in scikit-learn. Classification report. Classification report kind of just puts together all of the metrics that we've talked about. And we can go there. But I've been talking a lot about torch metrics. So let's look up torch metrics accuracy. Torch metrics. So this is a library. I don't think it comes with Google Colab at the moment, but you can import torch metrics and you can initialize a metric. So we've built our own accuracy function, but the beauty of using torch metrics is that it uses PyTorch-like code. So we've got metric, preds, and target, and then we can find out what the value of the accuracy is. And if you wanted to implement your own metrics, you could subclass the metric class here, but let's just practice this. So let's check to see if I'm going to grab this and copy this in here. If you want access to a lot of PyTorch metrics, see torch metrics. So can we import torch metrics? Maybe it's already in Google Colab. No, not here, but that's all right. We'll go pip install torch metrics. So Google Colab has access to torch metrics, and that's going to download from torch metrics. It shouldn't take too long. It's quite a small package, beautiful. And now we're going to go from torch metrics, import accuracy. Wonderful. And let's see how we can use this. So set up metric. So we're going to go torch metric underscore accuracy. We could call it whatever we want really, but we need accuracy here. We're just going to set up the class, and then we're going to calculate the accuracy of our multi-class model by calling it torch metric accuracy, and we're going to pass it ypreds and yblob test. Let's see what happens here. Oh, what did we get wrong? Runtime error. Expected all tensors to be on the same device, but found at least 2 devices. Oh, of course. Now, remember how I said torch metrics implements PyTorch-like code? Well, let's check what device this is on. Oh, it's on the CPU. So, something to be aware of, that if you use torch metrics, you have to make sure your metrics are on the same device by using device-agnostic code as your data. So if we run this, what do we get? Beautiful. We get an accuracy of 99.5%, which is in line with the accuracy function that we coded ourselves. So if you'd like a lot of pre-built metrics functions, be sure to see either scikit-learn for any of these or torch metrics for any PyTorch-like metrics, but just be aware, if you use the PyTorch version, they have to be on the same device. And if you'd like to install it, what do we have? Where's the metrics? Module metrics. Do we have classification? There we go. So look how many different types of classification metrics there are from torch metrics. So I'll leave that for you to explore. The resources for this will be here. This is an extracurriculum article for when to use precision and recall. And another extracurriculum would be to go through the torch metrics module for 10 minutes and have a look at the different metrics for classification. So with that being said, I think we've covered a fair bit. But I think it's also time for you to practice what you've learned. So let's cover some exercises in the next video. I'll see you there.